So here's some examples from 7.5 that hopefully if you're stuck they can clear up questions. So this is number 10 in the book, and it's log base 6, 2x plus 3 equals 3. So remember, the first thing you always want to examine is where is the variable. And here's our variable. Remember, if we put this in exponential form, it's base, exponent, answer. So the variable's in our answer, so we want to use exponential form. So we quickly transfer this. This is our base. This is our exponent. Equals 2x plus 3. And now we can just solve for x. So if we do 6 to the third, that's 216. Let's check. 6 to the third power, 216, equals 2x plus 3. Now we subtract 3 to solve for x. And we get 213 equals 2x. And we divide by 2. So 106.5 equals x, and we're done. So again, the key, remember, because the variable's not in the exponent, we don't need logarithms, and so we go through and solve that. So that's number 10. Number 12 says log base 3 x to the 9th equals 12. So again, we decide where our variable is. Again, it's in our answer, so we can switch this to exponential form. So that would be 3 to the 12th power equals x to the 9th. Now there's a couple ways to do this. You can just type in 3 to the 12th. And that gives us 531,441. And then we just take the 9th root of both sides. And so on the calculator, that would be, we can just do the answer to the, remember, if you're going to take the 9th root, you take the 1/9 power, you do it as a fraction. So 1 divided by 9. And we get 4.32. And again, we're rounding these three places. So we get 4.327x. Now, another way you could do this is you could, back here at the top, take the 9th root right here. So these would cancel and we would get x equals, now here's, if you remember when we did fractional exponents, this is our numerator and this is our denominator. So it becomes 3 to the 12/9 power, which reduces to 3 to the 4/3 power. And so we can now do that on the calculator. 3 to the 4/3 power. And again, we get the same number, 4.327. We'll do 14 next. So 14 says log 50 plus log, and then it's x divided by 2 equals 2. Excuse me. So again, our exponent's over here, so our variable's not there, so we want to get rid of the logarithms. But now we have 2 logarithms, so we need to get it down to 1. So we want to remember that addition can be rewritten as multiplication, so that becomes log 50 times x over 2 equals 2. 2 goes into 50 25 times, so we get log 25x equals 2. Now we can put it in exponential form. There's no base, so that's base 10. So 10 squared equals 25x. 10 squared is 100. And then divide by 25, so x equals 4. Again, the key, get to a single logarithm so you can get it out of logarithm form and into exponential form, and then solve for x. 16. Log, and it's x plus 3/10 plus log x 0. So a little bit different here. We have this plus 1 here. Again, our variable, here's our exponent, or here's our exponent once we move it over. So I'm going to head and move that negative 1 to the other side. So I'm going to subtract that 1. Now I'm going to put it in, I got to get from 2 to 1, so addition becomes multiplication. So I get this plus 3/10 times x equals negative 1. Distribute that, and I get x squared plus 3/10 x. And now I'm going to put it in exponential form, so my base is 10. So 10 to the negative first equals x squared plus 3/10 x. Ten to the negative first is 1/10. So I have to, because it's a quadratic, I want to set it equal to 0. So I'm going to move that 1/10 to the other side by subtracting. Now, you could use the quadratic formula with the fractions, but my advice would be to get rid of the fractions, so just multiply everything by 10. So I'm going to multiply every single term by 10. So we get 0 equals 10x squared plus 3x minus 1. And then we can try and factor that. Negative 10 and 3 would be 5 and negative 2. Because a is not 1, we have to build our box. So we get 10x squared. Remember, first term in the first box, last term in the last box. And then these fill the other two, 5x and negative 2x. Well, the greatest common factor, 5x and 1. And the first term is negative, so minus 1. So we get 5x minus 1. And then greatest common factor here is 2x plus 1. You can always check this to make sure it works. 10x squared, yes. 5x and negative 2x is 3x and negative 1. So our answers are 1/5 and negative 1/2. Now, when you go back, remember, you can't take logarithms of negative numbers. So up here, if I put in that negative 1/2, it's a log of a negative number, so that eliminates negative 1/2, and so our answer is just 1/5. You could have used a quadratic formula with the fractions and put in decimals, and then you just get 0.2, but it's the same thing. So that was number 16. Next, let's do 18. Now I know the book asks you to do this as on the graphing calculator and just trace it and find it. But I'm going to go through, and I'd like you to just solve these by doing what we've been doing. So this one's a little bit tricky because you haven't seen something like that before, but the variable is in the exponent, so we want to use logarithms. But what we have to remember here is this is the same as this, because remember you distribute the x, so it would be 2x times 3x. And so I can rewrite this as 6 to the x is less than or equal to 7,776. Since the variable is in the exponent, we want to use logarithms. So what we're going to do is we're just going to add that logarithm to both sides. So log 6x, and we're doing it base 10, so we can do it on the graphing calculator. Log 777.6. I can bring this x that's in the exponent, I can bring that out front and write it this way. And then divide by log 6. So x is less than or equal to, and then we just go to the calculator. And we take log 7/6 divided by log 6. And the answer is 5, and so x is less than or equal to 5. Since x is in the exponent, it can include negative numbers, so we can go ahead and leave that as x is less than or equal to 5. Let's take a look at 24. 24 says 1/2 to the negative x is equal to 1.6. Again, the first thing we ask ourselves is where's the variable, and it's in the exponent, so we want to add logarithms. So again, we're just going to add the log to both sides. 1/2 to the negative x, 1.6. Remember, if it's in the exponent, I can bring that out front. So negative x times log 1/2. And then divide by log 1/2 to both sides. So now we go to the calculator. Log 1.6 divided by log. Now you can go 1/2 or you can just go 0.5. And we get negative. And again, we're rounding 3 places, so 0.678. And then because this is negative, we want to solve for x, so it just changes the sign on both sides. So 0.678. Let's take a look at 26. Three to the x divided by 2 plus 1 equals 12.2. So again, ask yourself, where's the variable? It's in the exponent, so we want to add logarithms. So I'm just going to add a log to both sides. Now, you can do this in 2 steps. I kind of like to just bring this out front right now, because I'm going to bring it out front anyway. Instead of doing it in 2 steps like we did before, equals log 12.2. We've got to get x by itself, so I'm going to divide by log 3. So that gives us x over 2 plus 1 on this side, because these will cancel. And log 12.2 divided by log 3 is 2.277. Subtract 1. 1.277. And then it's divided by 2, so we multiply both sides by 2. .554. And we're done. So again, it's all important is deciding where it's at. Let's do one more problem. And this is one from your assignment. So number 30. This is one you had to do. Log 5x minus log 15.5 equals 2. So again, if we decide where the variable is, it's in our answer here. Remember, this is our exponent. So now we have to get rid of the logarithms. With 2, if it's subtraction, remember subtraction becomes division. So it becomes log 5x divided by 15.5 equals 2. Now you could go ahead and change that to decimal, but I'm just going to leave it right there right now. Switch it to exponential form. So that would be base 10 squared equals 10 squared is 100. Multiply. I like to do this since it's a fraction, just multiply by the reciprocal. You could multiply by 15.5 and then divide by 5, get the same answer. So 5 goes into 100 20 times, and 20 times 15.5, 310. Let's just check that. 15.5 times 20. Yeah, 310. So the answer would be 310. So that's just some more examples of how to do the work. Hopefully that helps you if you're stuck.